Hi.
Hello.
Hello. We're 8th period. And today is the 7th. All right, so we're using trigonometry again, but this time we're going to do it with we're going to name the angles. Because we can use trig in real world situations. This is literally how people do some of the things that they do in real life. So if we have a problem that involves looking up at an object, looking up at something, we're going to call that angle that our head makes from looking forward to looking up at the thing, the angle of elevation. Okay, so from looking forward to looking up at it is our angle of elevation. When we're looking down at something, our eyes looking straight forward, but we look down this time, that's an angle of depression. Okay? So looking up, angle elevation, looking down, angle of depression. Okay? Let's jump right into the examples at the bottom of the page. I have number 1 and number 2. Tell me which one you'd like me to work on.
2.
Number 2. All right. So join me toward the bottom of the page for number 2. You're changing your mind to number 1? Is everyone okay with that? You want to do number 1 instead?
Yep.
All right. Number 1. The angle of elevation from a point A to the top of the hill is 49 degrees. So here is the measure of our angle of elevation. And remember, that is, if I were standing here, that would be the angle. I would have to tilt my head back to look up at the top of the hill. If this point A, where Anna is standing, is 400 feet away from the bottom of the hill, we're asking, how tall is it? Okay? And we can use trig to figure this out. We have to find opposite, adjacent, hypotenuse sides for this right triangle that we've created. Here's our 90-degree angle. Where is the hypotenuse? Try again. It's on this side of the 49. Very good. It's directly across from the right angle. All right, if this is Anna standing at A for Anna, which side is she looking at? The height of the hill or how far away she is from the hill? The height of the hill. Because that's what she's looking at. That makes this side the opposite. Which means that the distance she is the adjacent. Bless you. Now let's go to our hippies to help us figure out which trig ratio we're going to use. Some old hippie taught another hippie. Tripping on. All right. We have no information on hypotenuse. We don't even have a variable. We're not even asked to find it. Our question mark, the thing we're looking for, our variable is here on opposite. So I have information on the opposite, that information being I want to know, and I have information on adjacent. As he said, we're using tangent. So I'm going to set up this triangle with tangent. The tangent of my angle of elevation is the opposite over the adjacent. If the question mark freaks you out, you can put a variable in there, whichever one's your favorite, like x. I'm going to use question mark. All right, we're solving for the question mark. What's happening between our unknown and 400? How do you undo divide? What do I multiply by?
400.
Good. You guys are masters. Dun, dun, dun. And so the unknown side that I'm looking for is equal to whatever I get when I go into my calculator and I type 400 tangent 49. What's the height of the hill?
160.47.
All right, it doesn't tell me what to round it to, so let's round it to the nearest foot. So that's this value here. Look 1 to the right. Is that number bigger than 5?
No.
No? So it's going to stay as is. This is a word problem. And so our answer needs to be in a complete sentence. The hill is about, I'm using the word about because I rounded, 460 feet high. That's it. Ask me a question.
What do you do if the variable is a question?
Great question. What do you do if the degree is a question mark? That's number 2. So shall we do that one? All right, let's do number 2 because that has our angle of elevation being the variable. I'm going to actually use a variable. I'm not going to use the question mark symbol. I'm going to use our variable theta, which is our go-to variable for angle measure. So I want to find theta when I know this side is 12.5 and this side is 18. So again, we need to go to our hippies. Some old hippie caught another hippie. Which trig function do I have the information for? I have a tangent again. It won't always be tangent. It just depends on what information I've been given. All right, so the tangent of the angle measure, which I don't know, so I'm using theta, is equal to the opposite over the adjacent. When my angle measure is the variable, I can find the measure of the angle by taking the inverse trig of whatever the fraction was between the two sides. All right, ask me your question so I can clarify this while people are typing. Okay, go ahead. I have a question. From here to here? What happened? Okay. So what's happening, the thing that I'm not writing, okay? What's happening is I need to break this tangent to get this by itself, okay? So just like when we were solving an equation and we wanted to break, say, a division, we would multiply because that was the inverse. I need to do the inverse of whatever tangent does. This is the symbol for do the inverse of whatever tangent does. So I'm going to apply that to both sides of my equation. These cancel because I have the thing and its inverse next to each other. And then the inverse gets applied here, which then I can just stick in my calculator. Okay? All right. And then now give me your number.
34.7778.
Confirmations? All right. Let's round that to the nearest tenth. To that one. 34 point. We're going to round to here. So
Eight.
there we go. 30 point. Ask a question. Okay, if no questions, let's go to the back side of the page because we can do something cool when we have more than one bit of information. Looking at number 3. Suppose we're trying to find the height of something tall, okay? But we don't have a way to measure how tall that is. This is how you would find the height of, say, a mountain. Okay? I cannot go to the mountain and like dig straight down at a 90-degree angle to the ground that the mountain is sitting on and then run a tape measure and say that's how tall it is. I can't do that. But what I can do is I can look at the mountain from 2 different standing points. I can figure out how far away I am Okay, the change that I'm making, standing closer here, I'm standing this much further away here. And I can track the angles that I'm looking up at the top of the mountain at. And using trig, I can calculate how tall that thing is. So that's what we're going to do today. This is what surveyors, people that go out and figure out how tall mountains or trees or buildings are to help build something like the school. Okay? This is what my mom and my dad did. No, I'm not good at this because of them. They didn't show me how to do this. I cried. Here's what we're doing. Here's the ground that our surveyor, that our person is standing on. Okay? He's looking, his eye level is 1.8 meters off the ground. Okay? So this part of the cliff is 1.8 meters up from the ground. Then we're going to find what this distance is and then add them together. Whatever the result is how tall the cliff is from the very ground to the very top. And we're going to use trig to make that happen. All right, let's figure out which trig functions we have. I have a right angle. I have two hypotenuses. I have one with that small triangle. And then I have a hypotenuse with this bigger triangle. From here, which side is our surveyor looking at? That's the angle we're making. What side are our eyes pointing? At the cliff or along the ground? It's pointing at the cliff, but our vision is moving along the ground. You weren't wrong. So then, because this is the side he's looking at, this is the opposite, and this then becomes the adjacent. So the adjacent is along where you're looking, and the opposite is the thing you're looking at. Which trig function uses opposite and adjacent? Tangent. So I'm going to write two tangent equations. I'm going to write the first one for this small triangle right in here. The tangent of angle 60 is equal to the opposite over the adjacent. Yes? Yep. I'm going to do it again for this bigger triangle. The tangent of 30. The tangent of 30 equals the opposite over, but now the adjacent isn't just y. The adjacent is this 50 plus my original distance. And my equations are kind of squished in there. So off to the side, I'm going to write them again, one on top of the other, okay? Just so that we can see them. Okay. So here's the first equation that or one of the equations I wrote. Here's the other equation that I wrote. Does not matter. The fractions are bothering me. Are they bothering you? Yeah, I don't like fractions in my equation. They make me nervous. So I'm going to go ahead and get rid of them. How do I get rid of fractions in an equation? Multiply by the entire denominator, which in this case is 50 plus y. Good. So that means that the left side of my equation is this, and the right side of my equation is that. I want you to note that I wrote this group in its own set of parentheses because I'm multiplying by that entire group. If I forgot the parentheses around the entire group, it would look like I'm multiplying the y first and then adding the 50 later. Okay? All right. I'm going to do the same thing to this and tell me if you're okay if I just write my result without showing my work.
Yep.
Okay. Yeah, I got your yup. Thank you. I was checking the other side of the room for yups. That's why I was so quiet. All right. Now have two things, this thing and this thing, equal to the same thing. They're both equal to x, which means they're equal to each other. And now I have a single equation, and the only variable is y. This is algebra 1, baby. Okay, so there's tangents in there, that looks confusing. Let's turn those into numbers. Use your calculators and give me tangent of 30 and tangent of 60. Let's go to 4 decimal places and then round. What comes after the 3? A 5, so then 7, 4. Confirmed? I got nodding silently works. Okay, I need someone to get me tangent 60, please. 1.7325? 05. So, okay, so 0.5, so round it here. At the 0, round it there. 1. Because the number after the 0 is 5 or bigger. All right. Much easier to deal with. I can distribute. Gonna need help with 50 times 0.5, whatever. 28.87. Combine like terms. Collect all the y's into one place. Again, going to need help with that subtraction. Yeah, these two right here. 1.1547. Okay, and now I need to get rid of this coefficient. Coefficient is the fancy math way of saying the number you're multiplying to y. And because I don't want to say 1.15, that's just too many numbers already, I'm being lazy and I'm saying coefficients instead of all of the numbers. Zero here. I feel a little uneasy about it being a 0 point something. Did you do 28.87 divided by 1.1547? $25.0022. Confirmed?
Yes.
Yes. Okay. This is the value of y right here. Did we answer the question? Really, what was the question? How tall is the steep cliff? Do we know how tall the cliff is yet? No. The good news is the steepness of the cliff is this value here, x. I can use either this equation or this equation to help us find that answer. And it doesn't matter which one you use. Pick your favorite. The top one or the bottom one? Yeah, I like the bottom one too. There's less work to do. So I'm going to use the bottom. Instead of y, I'm going to put the number that we calculated. And now I'm going to see what y'all's calculators give us when you take 25.0022 and multiply by the tangent of 60. Three five? Oh, 0.5. 0.5. Come on, fingers. My hand is not wanting to work. Confirm? 43.305? Yep. All right, so I'm going to write it over here on the right side of my paper on my figure. I'm leaving this showing because I know some people are still copying.
It's on.
I know, it's really tight. I wish I had like the full paper. Sorry. All right, so here. Okay, scooting over to the right, that's where I wrote it. So now this is the height of the steep cliff from the dude's eyeballs. Now we need to add in how tall the dude is so we can figure out how tall the entire cliff is. So 43.305 plus 1.8. Lay it on me. 43.305 plus 1.8. All right, and it says to the nearest meter. So I want to round it to that number. 45. Because the number after the 5 is a 1. All right, this thing is a word problem. So in the tiny little space I have left, I'm going to write my sentence that is the answer. My sentence is going to read something like, the steep cliff is about 45 meters tall. I'm writing that off screen right now. That's a CL, I'm sorry. I realize that looks like a D. Cliff. The steep cliff. Not the steep diff. That's weird. Steep cliff. All right. Number 4 is going to be the exact same way. Do you want to see that one? Yes? All right, let's look at number 4. Going to zoom out so we can look at number 4. The angle of depression from a hot air balloon to a person on the ground is 36 degrees. That's this angle of depression. So if I'm looking here, that's this angle. It's the same as if I were on the ground and looking up at the balloon. Okay, so I'm going to put it here as an angle of elevation, even though they told me it was an angle of depression. Okay, so they measure the same. If the person walks backwards 10 feet, our new angle is 26 degrees. If the person is 6 feet tall, how high up is the balloon? This is the exact same setup to what we just finished doing. So we're going to do the exact same process. Here's our right angle. That makes these the hypotenuses. There's the ground. That's 6 feet. I'm going to add whatever my result is to here, to 6, for my final answer down here. Here's the side opposite the person. There's the side adjacent to that person. Which trig function uses opposite and adjacent? Tangent, so I'm going to set up 2 tangent functions back to back. Tangent 36 and tangent 25. Ask a question. All right, I'm going to rewrite those equations off to the left-hand side where I have some more room to work on them. And again, it doesn't matter what order I write these in, just that I get them written down where I can see them. I'm going to clear the fractions in both of them. And when I do that, it turns them into stuff equals x. We're all right with that? Okay. This equals x, this equals x. I can set them equal to each other. Let's turn those tangents into numbers. When you're ready, please get me the decimal for tangent 25 and then tangent 36. Four decimal places and round at the fourth. Okay. Confirm? Confirm? Okay, both of them? He's the man. And you're awesome too. Going to distribute. Double check my numbers, make sure I'm not doing anything dumb up here. Happens way too often. Need some help with the 0.7 whatever minus the 0.4 whatever. Help. Is it a 0 on the front? 0.2. 0, 2. All right. That's a fun looking coefficient. I'm going to get rid of it. Y equals whatever I get when I do that. I don't know. 17.92.
Oh, medium.
8? Okay. All right, so that's y. Now it wants my answer rounded to the nearest foot, maybe? Let's go ahead and round it to the nearest foot, but I'm going to do that at the very end, okay? I'm going to hang on to this number just as long as I possibly can. Now that I have a value for y, I need a value for x. The good news is I have two different equations that'll give it to me. No one cares which one you pick. Pick the one that you like the best. The bottom one. All right, I'm down with the bottom one. So I'm going to put the value for y. Then I'm going to write the rest of my equation. And x is whatever I get when I take 17.9208 and multiply it by the tangent of 36. Whatever that is.
13.0202.
Here's our value for x. I'm going to go ahead and write it on my figure off to the right-hand side. It's off screen right now, just so that you can finish copying down what I wrote. All right, I'm going to slide over to the right so we can look at that figure again. All right, the full height of the cliff is the 13.0202 feet from the dude's eye level to the top of the cliff. And now I need to add his height, which is 6 more feet. So 13.002 plus 6 is 18, 19, 19? Okay. 19.0202. Let's round that to the nearest whole foot. So how high up is the hot air balloon? 19 feet. And so our final answer as a whole sentence is the hot air balloon is about 19 feet off the ground. That's it.